So let us continue with the last part of the sums of chapter 1. V is equal to AT plus B by T plus C plus V0 is a dimensionally valid equation. Now whenever they say like this, please understand that every term over here will have same dimension. So if this is velocity having unit meter per second and dimension as L1 T minus 1, every term will have same dimension. Okay. So what they have asked is they have asked to obtain the dimensional formula of A, B and C, where V is velocity and V0 is initial velocity. So we are done with this part. Let us talk about this part AT. Okay. So AT will also have the dimensions as L1 T minus 1. And we already have time over here. So time will have dimension as T1. Okay. Now let us, to find A, we will put this T1 on the other side. So that will become, or you can say it will go in denominator. Denominator में 1 है तो न्यूमरेटर में जाके -1 हो जाएगा. So you will have L1 is equal to L1 and T minus 2. So this is nothing but acceleration actually. Let us go ahead with this term, B upon T plus C. Okay. So B upon T plus C, this will again have same dimension, which is L1 T minus 1. Okay. Now before going on to solve this, let us talk about this denominator part. The denominator part is T plus C. Okay. Now whenever two terms are added, remember this, they both have same dimension. They both have same dimension. So first term is T, which stands for time. So the other term C will also have the same dimension as time. Therefore C ka dimension will be what? T raised to 1, or you can write it as L0 M0 T1. Okay. I hope you all understood this. This is from the logic that every term which is added have same dimension. So in the denominator you got time plus this uh, term C over here. So they both must be having same dimension. Time ka dimension is T1, so C ka dimension is also T1. Let us go ahead. So coming over here, this denominator ka dimension is T1, so we can write this as L1 T minus 1, and यहाँ पे denominator में you got dimension as T1. So let us put it like this. So T1 इस बाजू जाएगा, so you'll have L1 T minus 1 and T1. So this minus 1 and 1 will cancel out and you're left with this L1. So we got B as L1 M0 and T0, right? So we got A over here, we got B over here, B over here and C over here. Next, the length, breadth and thickness are given. We need to find the area and volume. Now area of a sheet is simply length into breadth. So you need to multiply 4.234 into 1.005. Now when you multiply this, you will get something around 4.2551 meter square. And what about volume? So volume is length into breadth into thickness over here, not height. So area we already got. How much is that? 4.25517 into volume over here is, if you observe this, this is given in centimeter. So we'll write it as 2.01 into 10 raised to minus 2 to convert this into meter. Now when you multiply, you will get something 4 to 8 के आसपास. The perfect answer is 8.56 into 10 raised to minus 2 meter cube, or you can simply write it as 0.0856 meter cube. Let us go ahead with the next sum. If length is 4 plus 001, radius is this, and mass is 6.25, 0.01. Calculate the percentage error in the determination of density. Now density is given by mass into volume. Now what is the volume of a cylinder? So volume of cylinder is given by pi r square h. Instead of height they have given length, so we'll write pi r square l. Right. So to find the error in D, we will write it as delta m by m plus delta r by r plus delta L by L. Now this radius is square, so we will multiply it by 2. So we have used that second type and third type of combination of errors, where we had z equal to AB and z equal to a raised to n. Now let us put the values. M is 0.01, 6.25. 2 into delta R is 0.001 divided by 0.0250 plus delta L is 0.001 divided by 4. So what we can do is, we can write this as 1 upon 625, multiplying numerator and denominator by 100. यहाँ पे we'll multiply by 1000, so you'll get 2 upon 225, 2 upon 25 plus 0.001 by 4. Now you can take LCM over here. You should get, अगर इसका 625 LCM लिया, so it will be what you all can do is, you can try this, take the LCM with this and multiply with this and tell me the answer that you'll get. Okay, you should send me this answer, right? Or just to verify, I'll give you all the final answer, 0.08185, but you all have to solve this and send to me. When the planet Jupiter is at a distance of 824.7 million kilometers from the Earth, its angular diameter is measured to be 35.72 minutes of arc. Calculate the diameter. Okay, diameter is given by alpha into the distance. Remember this formula, similar to that you had s equal to r theta in circle. This is alpha the angle, d is the distance. Now one thing is, alpha is given in terms of minutes. Now we need to convert this in terms of radians for this formula to be applicable. So to convert this into radians, we need to multiply this with 4.847 into 10 raised to minus 6. Okay, and then this will become in radians. When you will multiply, you will get 1.73 into 10 raised to minus 4 radians. Now there are some complex multiplications over here. We will be learning log very soon, and then we will try to solve these sums by log also. Okay, so this is the value of alpha. To find the diameter, we'll multiply alpha into d. Alpha is 1.73 into 10 raised to minus 4 into d is 8.24.7. Sorry, it is 824.7. Million is 10 raised to 6. Okay, remember this, million is 10 raised to 6, and this kilometers needs to be converted into meter, so 10 raised to 3, that makes it 10 raised to 9. The final answer will be 1.428 into 10 raised to 5. I've converted this back into kilometer. Let us see the next sum. This you should try on the basis of second and third part of combinations of error. This also you should tell me. There are 4 rules of significant figures. Tell me how many significant figures are there in all 4. And last wala is volume of sphere. Volume of sphere is given by 4 by 3 pi r cube. Try to solve this and send the final answer to me. Final answer is 5.13 centimeter cube. Try it out and send me all the answers.